Hello, my name's Shaun. Today I'm going to talk about identity and access management attacks. We'll cover common attacks. We will look at threat hunting and detections and how you can find those attacks. And I'll also look at mitigations and controls that you can put into place as well. I do work at Okata, but this is a completely vendor-neutral talk. The idea is that whatever identity platform you're using, you should be able to take away some valuable information. These are the 5 attacks that I will be discussing today, and I'll throw in a couple of others as well. So we'll talk about password spraying, brute force guessing of passwords. We'll talk about credential stuffing, using stolen credentials. We'll talk about adversary in the middle and some advanced phishing type scenarios, push bombing, MFA fatigue type of attacks, session hijacking, and if there's time, we'll do a little social engineering as well. I'm going to start off with a very basic example of a workforce identity solution. And by the way, I'm not going to talk about governance or PAM or Active Directory or on-premise type solutions. We're talking cloud-based workforce identity solutions here. And we're just starting off with no pre-authentication controls, single factor, only password-based authentication, no post-authentication. And we're going to see how bad can things be? What kind of attacks are going to be successful? I'll give a scenario overview. I'll talk about the attack. We'll look at some logs and query examples as well. So we'll talk about threat hunting and detection, and then I'll talk about mitigation. So by the end, we will have numerous controls in place. I suspect that your own identity solutions that you have configured at your companies will fall somewhere in the middle. You won't be as insecure as this. I would guess that you're not going to be as secure as our final solution, but we'll see. So scenario 1, we'll start with a password spray attack. This is for, again, an IAM platform in a workforce scenario where it is just password-based authentication. Very common to see password-based attacks. And by the way, I work with customers on a daily basis and help them when they are attacked, making recommendations for how to better secure their tenants. So when password spray attacks happen all the time, you're going to see lots of failed password attempts in the logs. And in the simple cases, when you get lucky, you're going to be able to look at common attributes within the request. You're going to be able to see things like IP addresses. Your identity platform may provide the ASN automatically. It may inject that for you, which will be like a grouping of IP addresses associated with an organization. You'll be able to see geolocation information like country or state. And in a simple case, you'll be able to find maybe countries or states where you don't normally have traffic from. So especially if you're a healthcare or financial organization that's in the United States, you may never have traffic from Russia or Iran, and suddenly you get a ton of it. So you're looking for common patterns, and that'll allow you to put forth a blocking rule. So network blocking at the identity platform level, it's a powerful control. And a lot of times workforce tenants, they can have maybe a half a dozen or more countries that are blocked. And just being able to exclude those, it's going to have a lot of password spray attacks that are mitigated as a result. Sometimes a lazy threat actor is just going to have a handful of IP addresses, just a couple of ASNs, and that's another quick win when you can block those at the network zone level. Now, most identity platforms provide a mechanism for finding password spray attacks and blocking those. Excuse me. And the way that these typically work is that the identity platform is going to have to look at a series of requests over time before it's able to start blocking. So what that means is in your logs, you'll be able to see some indication that an attack has started, especially if it's a clever threat actor. Maybe they don't have an abundance of traffic at first. And so the identity platform eventually will start blocking. So what that means is there is this period of time where this attack may have been successful. And so once you have the attributes, whether it's country or IPs or ASNs, you're going to need to go back in a threat hunting exercise and look to see if any of those authentications were successful with those indicators. Same thing for your network zone blocking. Especially if this is a manual exercise where you have your security operations team that's looking for indicators, and then they initialize a block. They're also going to need to go back before that block occurred and see if there are successful authentications. If there are matches found, you typically want to reset the password, clear the session. If there's associated access or refresh tokens, you want to revoke those. And I'm going to go ahead and introduce another control at the IAM platform level, which is to add a workflow or an action. There's lots of different options for low-code type of automation. There was a Times presentation this morning, I think, in this room. So lots of options, but by using the tooling inside the platform itself, it usually makes it easier to do common identity-related things like reset passwords. So often it's an easier way to go ahead and implement those. Okay, so we've already updated our diagram. We have some network controls already in place. So we've added some things on the pre-authentication side. If your identity platform has password spraying protection, you want to go ahead and enable that and set that to blocking. And then down there in the blue, I also have some workflow or action type of automation that's going to make life easier for your SecOps team. And that could either be event-based or it could be something that they go and trigger by providing some inputs like user IDs to have their passwords reset. Unfortunately, though, password spraying attacks aren't usually that simple where you have just a couple countries or a few IP addresses. Oftentimes, IPs are rotating, and that is a more difficult thing to deal with. I will say, though, in some cases, you'll have a threat actor that goes through the effort of making sure that they have IPs from all over the world, maybe just 10 requests per IP address from all over the world, but then they do something like have a typo in their user agent, so it's obviously fraudulent. I've seen a large-scale attack where the threat actor put the word user agent in the user agent. I have seen when it's completely empty, when it's set to unknown, when it's a completely fake user agent, something it's a non-existent Chrome version, for example. So all those things can also be available right in the request, and they're easy to search for. But in other cases, you need other values. So a JA4 fingerprint is a valuable thing to search for as well. It's a hash signature that represents the TLS cipher suites that are used, some network metadata like packet size, and with that you can find a series of requests that have that same fingerprint, and you can search for that as well. That's something that your identity platform may or may not have in the logs. That's not widely available. But anonymizing proxies is something that's usually present. So a flag saying whether an anonymizing proxy was used, meaning that the threat actor was trying to hide their IP behind a proxy. So in this more complex case, you might need a complex blocking rule. So in ACL, that's sometimes available in an identity platform where you are able to take maybe a user agent in combination with the fingerprint and block also if it is an anonymizing proxy. If you don't have that capability within your platform, then you can front your identity provider with a WAF, and at the web application firewall level, then you can have blocking rules there. But definitely easier if it's just built into the identity platform. In many cases, for the workforce solution, you can just block anonymizing proxies altogether. This seems to really depend on your industry. We've seen university cases where they don't have that capability without impacting legitimate users. But for a lot of companies, you can just block this type of anonymizing proxy altogether. Okay, so we've added more controls. We continue to build out our diagram. We either have a WAF or ACLs that's fronting, so that's more pre-authentication controls, blocking anonymizing proxies, but we're still using single-factor authentication, though. I will say strong password policies are a must. If you want to adhere to the NIST, 863B, 12 characters at a minimum, but really important control for password spraying is to block common passwords in most identity providers. They have a very large database where you can block those altogether. Next up, credential stuffing. So if credentials are stolen, and it's easy to purchase in the dark corners of the internet large lists of stolen credentials, then a threat actor may try and loop through all of those and see if they can log in. And so you're going to see two types of logs in that case. You'll see successful authentication events, but you may have a high risk score associated. Most identity platforms are going to inject a risk score into your logs, so you'll be able to see a high or medium for things like a new device is used, a new IP address is used, maybe it's impossible travel. Those attributes can be useful in detecting credential stuffing, but you'll also see some failed authentications, but with a non-existent or unknown user. that is common as well. So you can search for both of those things. One problem is though, you're going to get some legitimate, like normal user traffic that has hits for those as well. I've got a couple example queries here. So we've got unknown user failed auth events, and then we've got high risk success auth events to look for credential stuffing. One of the good controls to enable is breach password detection. Some identity platforms have this baked in for free. Sometimes it's an extra cost. Sometimes there's different layers or level to it. But where possible, you want to leverage this feature. And then if you can, log out users immediately. Maybe you can run more custom automation here, a workflow as an example, and then notify the users. Maybe you want to notify your SecOps team, although that can be maybe too noisy and have too many notifications. These workflows can also be used to send Slack messages, open up tickets, that kind of thing as well. So we've been talking about single factor authentication, but of course, we're going to build up to multi-factor and at a minimum having adaptive MFA. We looked at the risk attributes already. If there is high risk for one reason or another, maybe it's a new device, a new location, impossible travel, then at the bottom here, and hopefully you can read that, you want to be able to trigger a second factor. So in the next scenario, we're going to talk about SMS or OTP building up slowly to a more and more secure architecture here. End users should be able to get notified when there's a high-risk login event, and they should be able to report suspicious activity. And then your security operations team, at a minimum, we'll start with the manual, they should be able to investigate and then reset passwords, clear sessions, and so on. You could also automate this with a workflow, and later on we'll talk about more advanced type of solutions. I'm going to try not to say AI, because I think everybody's heard AI 1,000 times today. So yeah, threat hunting, looking for suspicious activity, looking for high-risk logins to high-risk apps. Some companies have very large SecOps teams where they can write detections, and they have people available globally where they can investigate these. And other times you really have to limit the amount of time that you can put towards investigating these kinds of things. And so looking for just high risk, finding just your high-risk apps, I can tell you that it's the payroll app that gets targeted most commonly, by far. And also your identity management, the admin console. Those are the two things that are targeted in other financial apps as well. It's common in bot attacks that as soon as they have successful account takeover, they're going to loop through and try to access as many apps as they can. We're probably storing that like in a database for someone else to leverage in the future. But rapid application access, that is a good detection to have in place in order to find malicious activity. Okay, so we're adding more and more controls as we go. We've enabled breach password detection. We've started talking about adaptive MFA and adding secondary factors, notifications for end users so they can report suspicious activity, and also blocking user enumeration is really important. Oftentimes through APIs, the password reset or even the login page, based on the error message, you can tell if it's a legit user or not. And that is really problematic in credential stuffing attacks. So you want to make sure that your user base can't be enumerated and isn't leaked in other ways. But if we have a second factor now, we're moving towards MFA, but adversary in the middle, unfortunately, is a mechanism for bypassing that second factor. So beyond just the traditional phishing, which is looking to steal passwords, adversary in the middle attacks, they will try to steal the password, also prompt with a proxy in the middle for that 6-digit code. This could be SMS, this could be an authenticator app with a one-time passcode, but it's going to prompt for both of those, and in the end, be able to steal the session as well to make it easier for them to do bad things. So the detection here, it's really similar to the credential stuffing ones that we just talked about, but also looking at application logs is really important as well. The payroll system, is somebody changing where your paycheck goes? That's the kind of thing that you want to have application level checks for as well. What else? When a threat actor does bypass that second factor, what do they typically do? They're going to try to activate or enroll another authenticator. They're going to want to make it easier for them to get back in later. So looking for activations and deactivations is a really important detection to have. For the SMS case, you will see that when that second factor is activated, the new one that is, that they'll often use the same phone number. So you can search for the same phone number being used over and over again. That's a good way to catch the malicious users. And then MFA abandonment. Sometimes they don't get past the second factor. So looking for an abandoned MFA prompt, that's a good way to find them as well. Now I mentioned that you want to have detections at the application level, including your IAM admin console. So oftentimes if a threat actor gets access to your identity management console, then they're going to do things like downgrade authentication policies. They're just going to remove multi-factor, at least for some applications. Other times, though, they're going to set up another identity provider. So they're going to set up a federation trust relationship with an IDP that they control, and then that way, their bad guy friends can log in through that way. So it just makes it easier for them for future logins and future access. So the mitigation here is to use a higher assurance factor. So next we're going to talk about push notification. So I bet everybody's seen this push notification in one type of authenticator app or another. It's the yes or no button. And the problem with this one is that if a threat actor gets access to credentials, then they can kick this off over and over and over again. And surprisingly, folks sometimes will just click the yes button. It happens. So what can you do? How can you find this? You can look to see when push notifications are rejected. Hopefully your logs are detailed and granular enough in your identity platform where it won't just be a failed, it'll be a deny. It won't be a, you want to be able to distinguish between a deny and a timeout is what I'm getting at here. But this ends up being problematic, and I can tell you that it often ends up being a really complex query in order to find when this is legitimate bad behavior. So you want to look for multiple consecutive push rejections without an accept in the middle. So yeah, I was going to show this query, but it's really long and complex. And that's why I would just recommend enabling a number challenge. Most likely, if you have an authenticator app that supports push notifications and that's what you're using, usually it's just a button click or a checkbox to enable the number challenge. While this is still not fully phishing resistant, you're much less likely to have an incident with a number challenge where you have to match up the number from the login screen to the authenticator app. So much less likely. So this is a quick win, and I would definitely recommend it if you're using push notifications with a yes, no right now. Even better yet, though, is WebAuthn and passkeys. And I bet everybody has heard of this already, so I'm going to go really quickly here. From the FIDO Alliance and W3C, both of them are specifications involving public key cryptography. Both of these are about passwordless, moving away from password-based authentication. WebAuthn came first, and it had information about hardware keys, or I've got a YubiKey here that was given earlier today. Biometrics, Face ID, those kinds of things, fingerprint readers. So WebAuthn came first, and then passkeys came later to be even more user-friendly. One of the things that passkeys offers is that syncability that you have with other devices, which does have some security concerns, but it does address some of the usability concerns. And so I have an interesting chart here because I do believe that there is a misconception that WebAuthn and passkeys offer such a poor user experience that folks aren't migrating quickly enough to them. This QR code, I know people are skeptical about QR codes, but this QR code takes you to a white paper on the secure sign-in trends from Okta, a really good resource if you're trying to make a case for your company. You're talking to stakeholders and you want to recommend WebAuthn. This has extensive information about usability versus security. Again, WebAuthn has that security phishing resistance benefit. But what about the challenge time? Well, surprisingly, the challenge time is actually lower for WebAuthn. It's 4 seconds on average, whereas things like SMS is 12 seconds on average, and you've got push notifications are 9 seconds on average. So at least in terms of the challenge time, the usability for WebAuthn, it is a win. I've got another diagram here with a usability score on the bottom and the security score on the left there. And so you can see WebAuthn scores really high on both of those. And if you want to know how that usability score was tabulated and the different things that they considered, then you can go check out that white paper. Okay, so for scenario 5, we talked about push notifications. We talked about the quick win with the number challenge. and also WebAuthn and moving to phishing-resistant factors. But let's say that you fully move over to phishing-resistant factors, and there is still a risk of session hijacking. So that cookie in the browser can still be stolen. And if you're wondering if that's actually a real issue, it definitely is. 94 billion session cookies were stolen last year, according to the Verizon Data Breach Report. You may have some built-in detections in your identity platform that'll tell you if your ASN changes with an existing session. And that's good, but I switch between VPNs. My ASN changes sometimes, and I bet yours does too. User agent changes less frequently in the middle of a session, but every once in a while you update your browser, and so your browser version and your user agent will be incremented. So you need a more sophisticated detection here. Ideally, your platform level would do that for you. And I want to talk now about a control called universal logout. So universal logout for the stolen session use case, where we have Dakota here who's logged in. She's done phishing-resistant authentication. This particular authentication policy also requires that she's on the corporate network zone, and she is. But sadly, it's Jordan who steals her session cookie. And luckily, the identity platform, and I said I was going to try not to say AI, but this is going to be where the advanced machine learning and big data analysis, that kind of thing, is working within your identity platform to detect that maybe it's not just the ASN and the user agent, but maybe it's a traffic that matches in other tenants across the global hierarchy of tenants. And so as a result, the authentication policy gets triggered again, and now Jordan's IP address is not in the proper network zone, so he is denied access. But even better, universal logout gets triggered, so the identity platform session gets terminated, any access tokens get revoked, and also applications that are supported also have the application session terminated as well. The user account can be suspended through our workflow automation, and then the SecOps team can be notified. I'm going to go quickly here because I'm running low on time, because I want to talk about the shared signal framework, which is a relatively new specification, helps with the malware case. I bet most of you have endpoint detection that's running on your devices. And with that tooling, it can act as a shared signal framework provider, sending signals to your identity platform. So this is an open specification that many identity platforms are starting to support. And then the identity platform can then trigger universal logout. So poor Dakota again here, she logs into her identity platform, she goes to her CRM solution, but then she gets phished. She has malware that's downloaded, but luckily she has EDR running on that device. It's going to send that high-risk signal about malware being on the device, and so universal logout gets triggered, and this is a better visualization about the identity session that gets terminated, and also the application session gets terminated. So this is a big win, and think about how much faster this is versus having a security operations team investigate and try to make that call and then manually doing the revocation. Okay, so shared signal framework, very valuable, relatively new though, so there isn't a huge list of vendors that support it, but it's growing. Okay, so let's say that you're doing phishing resistance and you have a clever threat actor though who has managed to get their hands on the password. They can't get past that phishing resistant factor, they can't get past the WebAuthn, but they are happy to call the help desk, and make their case and sob story about how they lost their phone or whatnot, and then convince the help desk person to reset the factor. And I mentioned this is a good detection to have about factors being reset and a new one being created. So what can you do? ID verification or ID proofing. This integrates with many identity tools, and I've tried to take out anything specifying the particular vendor here. What this is doing is requiring a government-issued ID, so a driver's license, a passport. We use this at my company, and it works really well, and it's relatively fast. So not only do I hold my passport up here, but it's also going to do a live image selfie verification, so it's going to look at me and compare that to the picture on my ID. So it works. There are some areas where it can be circumvented, but it is a viable control. So here we go. This is our final diagram here. We have pre-authentication controls, we have network zone configurations, we have a WAF and ACL for complex blocking rules, We've added multiple attack protections, breach credential detection, password spraying protection at the platform level, put those into blocking mode. We looked at different authentication methods. We decided that WebAuthn is the way to go. We looked at adaptive MFA, but really for your high-risk applications, you should have authentication every time. In the post-authentication area, we started talking about user notifications so that they can report suspicious activity, but we should also have things like the shared signal framework so that our device integrations, EDR-type solutions, they can report in and share those signals so that we can trigger universal logout. Super important for session hijacking. And then for social engineering cases and to prevent factor resets and factor activation, ID proofing is a valuable control as well. So I will leave you with 3 areas to focus on for your identity program. 1, what is your phishing resistant percentage for all of your applications? And what is your phishing resistant percentage usage for your high risk applications? So I think that you might be surprised that it's maybe not as high as you thought. Sometimes it also goes backwards if you have an authentication policy change. This is the main metric that I would have for my identity program. In your monthly or quarterly meetings, I would put this at the top of your program summary. Set a goal really high, 80% across all applications, 100% for high-risk applications, and make sure that phishing-resistant authentication is one of your main goals if you're not there already. Then having advanced session protection. So being able to detect session hijacking, trigger universal logout, revoke tokens automatically, doing it almost instantaneously, that is a goal, using the shared signal framework and adopting that as well. And then lastly, for social engineering attacks, adopting identity verification and ID proofing, and I'll say also for the customer identity use case, this can be really valuable for the registration use case. So here we go. I have on the left the QR code again for the Secure Trends report, but on the right, I have a GitHub repo, and I will say that this is vendor specific, but it has dozens and dozens of detections. Some of them I talked about today, but there's even more detections. So if you're not using this particular vendor, you can port those over and make sure you have those same kind of detections. There's also a separate list for threat hunting, things that are a little bit noisier, but still valuable. All right, and I think I might be over just a couple minutes, so thank you all for listening and not heading to happy hour early. But thank you very much for your time.